Alright, here we go again. I haven't made a video in a really long time. Everything I've uploaded have been re-uploaded, so this is me going back to making videos. I'm gonna see whether this handheld view is clear enough or whether we need to also show the screen. So we'll see how we go, but this is question 1 of the application of differentiation worksheet. This only has differentiation, so in the future we're going to do questions that has everything. Okay, so part A, consider the function f r to r. So the domain is r and the codomain is r, and f(x) equals to 4x cubed plus 5x minus 9. You need to first of all find the derivative of x, so that's really straightforward. And then you need to explain why the derivative is greater or equal to 5. So I'm going to start with just find the derivative. You can definitely do this in the class, but I actually don't know what that is. Okay, but you probably should be able to do it by hand. I need to investigate that. So just multiply the power with the coefficient. So bring the power to the front and reduce the power by 1 plus 5. And negative 9 just have the derivative of 0. So this is a derivative. Now for part B, part 2, you need to explain why the derivative is greater or equal to 5 for all x values. This is a derivative 12x squared plus 5. Now explanation or proof that it is greater or equal to 5. A few ways to do it. You could draw a graph if you want, I guess. So if we draw a graph, then this is a parabola. It's a positive parabola that has a turning point at 0, 5. So if you look at the graph, you can clearly tell that this derivative can never be less than 5. Now what I tend to do, I'm not a graphic person, I think. My first instinct is always to use algebra. You probably can start with x squared is greater or equal to 0 for all value of x. It doesn't matter what x is, the square of a number is a non-negative number. Therefore, 12x squared is going to be greater or equal to 0 as well, and 12x squared plus 5 will be greater or equal to 5. So it's only a mark, and I think having this line is probably covering that mark already. So that would be part A, pretty straightforward. And then you have part B. So now B, instead of having numbers, you have more pronumerals. Try not to get intimidated by that. The cubic function P is defined by P. So domain still R and codomain still R, and P of x equals to ax cubed plus bx squared plus cx plus k, where a, b, c, and k are real numbers. If P has m stationary points, so m in this case would be the number of stationary points that P can have, P being the polynomial. What possible values can m have? Okay, let's say you read this question and you have no idea what to do. Because the question has stationary points, so we're talking about number of stationary point. Now, if you recall what stationary points are and how you can find them, the number of stationary point is the same as the number of solution for the equation of the derivative of p, so p dash of x equal to 0. So the number of stationary point, it's going to be the same as the number of solution for p prime of x equal to 0. So I need to find the derivative, which is going to be, so if you use it in terms of a, b, c, and k, then you have 3a squared plus 2b, sorry, I forgot the x, so 3a x squared plus 2bx plus c. So this is the derivative. And if you want to, so basically the question is asking you how many solutions. So if I have 3x squared, I need to learn to copy things properly. Okay, so 3ax squared plus 2bx plus c equal to 0. It's going to be the equation that I need to solve in order to determine the number of the number of stationary points. And because this is a quadratic equation, you can have 1, 2, or no solutions. So m can equal to 0, 1, or 2 because quadratic equation can have 0, 1, or 2 solutions. Equation can have 0, 1, or 2 solutions. Okay, so that's the first part. The second part, if p has an inverse function, what possible value of m can m have? Okay, so if p has an inverse function, if you go back to what the requirement is for an inverse function, then you need p to be a one-to-one function. So p of x must be one-to-one. So it needs to pass the horizontal line test, which means that there is no, if you draw a horizontal line, it should only cut the graph once. So if you think about what the cubic graph looks like, it could look like this or like this. So the difference between the first and the second case is a little bit subtle, but this is when it doesn't have any stationary points. This is when I really need more space, but this is when m equal to 0, and this is when m equal to 1. And if m equals to 2, if you have 2 stationary points, then you would have a maximum and minimum, something like that. You could have a negative cubic graph, of course. So if you want p of x to be 1-to-1, then you can't take the situation when m equal to 2. So m must equal to 0 or 1. So you can have either of these cases, which actually gives you a 1-to-1 function. Okay, so that's part B. Part C, the cubic function q is defined by q of x is 3 minus 2x cubed. Write down an expression for the derivative. Sorry, the inverse function. Now, because the question is worth 2 marks, I am going to show full working out. I'm also going to show you how to check your answer with the CAS, even though sometimes it helps, sometimes it just makes it a little bit more confusing because of the different notations. Okay, so q, we have y equal to 3 minus 2x cubed. So if you have the inverse, what you need to show is that you understand that you need to switch the x and y values, and I'm going to just move the 2x cubed to the other side. So 2y cubed equals to 3 minus x, which means that y cubed is 3 minus x over 2. Therefore, y would equal to the cube root of 3 minus x over 2. Now, if you want to answer the question, q inverse of x equals to the cube root of 3 minus x over 2, and put in domain, x is real because there's no restriction on the domain and range here. Actually, I don't think that's right. Is that right? Yes, this is a cubic function, so if the dome of q inverse is going to equal to the range of q, which is just r, because if you think about the shape of a cubic function, this one's going to look like something like this. So it definitely can cover every y coordinate. Okay, so that's the first part. Oh yes, so if you want to check your answer in the CAS, menu 3.1, menu what? I don't even know what I'm doing. Okay, let's not do that. Let's try again. Control I, get rid of here. Control, yeah, this is going well. Delete. All right. I don't want geometry, I need a calculator. So very simply, you could define q if you want. In fact, I might do it. So define q of x equal to 3 minus 2 times x cubed. Okay. And then you just need to solve q of y equal to x because you're solving for, you're swapping the x and y coordinates. Okay, so you have -2. This is what I mean by sometimes it's quite hard to check. Let's see. Now one, it's like a trick that I do, and most of the time it works, but not all the time. Sometimes you want to check whether your expression actually is an equivalent of the expression in the cast, you could just subtract them, or you can draw two graphs. So you can do a graph of your answer and the graph of the expression that you get in the cast and see whether you get the same graph. Sometimes the graph method is better because sometimes, especially for circular functions, they just manipulate it into something else. But okay, so if I subtract the answer from the cast from my answer, I get 0. So my answer is correct. All right, part 2, determine the coordinates of the point of intersection of the graph of y equal to q of x and y equal to q inverse of x. All right, the point of intersection between these two. Now, obviously, because you have the cast calculator, I think you can solve. So in cast you can solve q of x equal to q inverse, and that should work. So solve q. I probably should define this as something. Define, I don't know, in qi, so inverse of q of x equal to, I'm going to define it is equal to this thing. Probably should delete the y. Okay, so we're going to solve q of x equals to qi of x, and we're solving for x. You do get an answer, so you can solve in cast. The only thing is, I'm not sure. I think you might get away with it, but because the question is what 2 mass, so you probably want to show a little bit more working out than just solving cast, but you know that the x coordinate of this point is x equals to 1. So another way, if you don't have the cast and you have to do it by hand, you could solve for q of x equal to x, or you can solve for q inverse of x equal to x, because any point of intersection between a function and its inverse has to occur at the line on the line y equal to x. So you have that, even though to be fair, I'm still doing it in cast anyway. So I guess it doesn't matter. Or solve in cast. The only thing is that the first method would also work if you don't have a calculator, but most of the time, to solve for the solution of the function and its inverse by hand, it's really messy. So you get x equal to 1, there, and again, if x equal to 1, then y has to equal to 1. It has to occur on the line y equal to x. So the point of intersection is 1, 1. This is my final answer. So that's part C. Is there part D? Yep. Okay. The cubic function g. So this is all about cubic functions, different things that have to do with cubic functions. The cubic function g is defined by g r to r, so domains r, codomain is r, and g of x is x cubed plus 2x squared plus cx plus k, where c and k are real numbers. If g has exactly one stationary point, now once again, this is a roundabout way, but they are giving you the number of solutions for an equation. So if g has exactly one stationary point, it's the same as saying that g prime of x equal to 0. This equation has one solution. So naturally, I'm going to start by just working out what g prime of x is. So g prime of x is 3x squared plus 4x plus c. This is g prime of x, which is great because this is a quadratic expression. And you can control the number of solutions of a quadratic equations using the discriminant. So if you want 3x squared plus 4x plus c to equal to 0, it means that the discriminant must equal to 0. And the discriminant in this case is b squared minus 4ac. Oh, this is the same c, so that's good. Which is going to be 16 minus 12. So if 12c, sorry. If delta equal to 0, it means that 16 minus 12c equals to 0, which is the same as saying that c equals to 16 over 12, which is 4 over 3. I'm just going to write the answer. So c is 4 over 3 for the first part. Okay, I think I should write it on this side. C is 4 over 3. This is not the best notation, I understand, but okay. If this stationary point, wonder whether I have enough room. If this stationary point occurs at a point of intersection, so this is a stationary point, which means that you already know that g prime of x would equal to 3x squared plus 4x plus 4 over 3 in order for for it to have one stationary point. If this stationary point occurs at the point of intersection of y equal to g of x and y negative 1 of x, find the value of k. All right, in order to find k, I'm going to start by just finding x, because I know that this is a stationary point, so I can just solve for this equation. 3x squared plus 4x plus 4 over 3 equals 0. So 3 times x squared plus 4x plus, we're going to go with 4 over 3. Not like that. All right, let's try again. Did I tap? No? What is going on? I think my cast is doing something weird. Okay, let's go with 4 over 3. And is there a reason why it's outside the bracket? Okay, now it's inside the bracket, equal to 0. I need to fix it. I don't know what's the issue. Okay, x is negative 2/3. Use a cast. It's only 3 max. Okay, so x equal to negative 2/3. Now, if x equals to negative 2/3, and if this is the point of intersection, so point of intersection between g and g inverse, then it means that you must have a hang on, let me check. And g inverse of x, then the y coordinate will also be negative 2/3. So negative 2/3, negative 2/3 would be the coordinate of this point, which means that if you want to solve for k, so you would have g of negative 2/3 equal to negative 2/3. And if I solve for k, I want to define everything, honestly. So just menu, I'm going to define g because I can. So g of x is x cubed. What is going on with this? Okay, plus 2 times x squared. Now I'm going to put in 4 over 3, and somebody maybe can tell me why. Oh yeah, because I tapped. Why did I tap? That was so dumb. Okay, 4 over 3x plus k. So that's define, and then we're just going to solve g of negative 2/3. Negative 2 over 3 equals to negative 2 over 3. Okay. And we're solving for k. So solve for k. K is negative 10 on 27, which I think is the answer. So we have k equals to negative 10 on 27. And that is the end of question 1. It's not too hard, but it shows how they can really ask questions relating to quadratic and cubic, especially quadratic number of solutions in the context of calculus. So the question and the theory behind it is not difficult. You just need to remember to apply. That's all. So that's it. Let's save this.